Welcome to section 13.6. We're dealing with another method for solving triangles that do not have a 90-degree angle, so they're not right triangle. This method is called the law of cosines. As we go through, here's one thing I want to say before we start. Round to one decimal place. So let's round to the nearest tenth, just so that we're all consistent on this. But here's one thing that we're doing. The law of cosines has three versions. It only has three versions because it varies on what sides you have. And so let me show you. In order to find side A, we say A squared is the same thing as equals B squared plus C squared. That should kind of remind you a bit of Pythagorean theorem. Minus 2 times B and C times the cosine of angle A. Because we're setting it equal to side A, we use angle A. Okay. Second version, if we have side B, I'm going to use the other two sides. So A squared plus C squared minus 2AC times the cosine of B. And again, we're using angle B, which is equal to side B squared. Last one, C squared is A squared plus B squared minus 2AB times the cosine of C. And again, we're going to give you the law of cosines equation, but you still should kind of know how it works. Now, here's the reason for the difference in this method. If you look at what we give you in question number 1, we give you side A, side C, and angle B. In the triangles we gave you in 13.5, we always had an angle and a side with the same letter. We call those corresponding. So I could always circle a corresponding angle and a side to be able to find it. Here's the problem. I don't have that this time. And since I don't have that, I have to look for another method because I'm not able to find the other angles. So what we do is the law of cosines. So I'm going to first start by finding side B because I know angle B. And so I'm going to start there. So for part A, I'm going to start by finding B by saying B squared equals. Now, if I look above, I'm looking at the other two sides squared. So 7 squared plus 12 squared minus 2 times 7 times 12 times the cosine of angle B since I'm doing side B. Now, as I go through, because I have all of the numbers on this side, what you can do is plug it directly in your calculator. 7 squared plus 12 squared minus 2 times 7 times 12 times cosine of 26. You end up getting that B squared is 42. So you square root it, and you get that B is approximately, and I want to round to one decimal place, so 6.5. Okay, so we found side B. One thing to keep in mind, finding a side is way easier than finding an angle. Okay, so I'm going to start next with part B. I'm going to find angle A. In order to find angle A, I need to set it equal to side A. So here I go. Side A is 7. So I'm going to say 7 squared equals. Now I know the other side is 12 squared. Now I'm going to have to use my 6.5, whether it's good or bad, I have to use it. So 6.5 squared minus 2 times 12 times 6.5 times the cosine of angle A. Now here's where our mistakes tend to happen. 7 squared is 49. What I would do is group together 12 squared plus 6.5 squared. You end up getting 186.25. Minus, now do 2 times 12 times 6.5. You end up getting 156, and then you have the cosine of A. The number one mistake people make is they try to subtract these two values, and you can't. This cosine of A is our variable, and so 156 is tied there. So you have to move the 186.25 first. 49 minus 186.25 is negative 137.25 equals, this negative still stays, so negative 156 times the cosine of A. I divide by negative 156, and I get that the cosine of A is 0.88. And I would go out 2 decimal places here because the farther you out on the angle, the more accurate it gets. But when I inverse cosine 0.88, what I find for angle A is you get 28.4 degrees. Now, I have no desire to do that process again to find angle C. And the truth is, I don't have to. I now know two angles. So in order to find angle C, all I have to do is 180 minus the 26 that was originally given, minus the 28.4 that I just found. And what I get is that angle C is 125.6 degrees. Now, law of cosines is a lengthier process, but sometimes it has to be done because we don't have the corresponding angle inside. So we're going to try another one. Let's slide to the bottom. All right, in question number 2, we give you 3 sides. Again, you can't use law of sines because you don't have a side and its corresponding angle. All right, so let's start by finding one of the angles. This suggests we find B first. The only reason I'd find B is I know B will be the biggest angle, so I'm going to find that one first, but it really, in the long run, won't matter. So let's start by finding angle B. Well, if I want to find angle B, I have to set it equal to side B. Side B is 13. So 13 squared equals 7 squared plus 9 squared minus 2 times 7 times 9 times the cosine of B. 13 squared is 169. We suggested in the last thing that you do the squares first. 7 squared plus 9 squared is 130. Minus 2 times 7 times 9 is 126 cosine B. Again, these two cannot be added together. I have to move the 130 to one side. When I do that, I get 39 equals negative 126 cosine of B. When I divide by negative 126, I'm going to round to 2 decimal places. So I get that negative 0.31 equals the cosine of B. And if I inverse cosine the negative 0.31, I find that angle B is 108.1 degrees. Okay, it is an obtuse angle. Based on our picture, it looks like it should be. But again, don't just assume, because our pictures will be inaccurate at times, especially if we're drawing them. So we found one angle. Let's find another angle. I'm going to find angle A. And if I'm going to find angle A, I'm going to set it equal to side A. Okay, so side A is 7. So I'm going to say 7 squared equals 13 squared plus 9 squared minus 2 times 13 times 9 times the cosine of angle A. 7 squared is 49. 13 squared plus 9 squared is 250. Minus 2 times 13 times 9 is 234. Cosine of A. Again, I move the 250 first. I end up getting negative 201 equals negative 234 times the cosine of A. When I divide by negative 234, I get 0.86 equals the cosine of A. And again, when you're doing an angle, I'd go to 2 places. When your final answer, you go 1 place. When I inverse cosine 0.86, what I end up getting is that angle A is 30.7 degrees. Now, if you want, you can do this one more time, but you'd be wasting your time, right? I have 2 of the angles. To find angle C, I take 180 minus 108.1 minus 30.7. What I end up getting is then the angle C is 41.2 degrees. Okay, so finding angles are way more time consuming than finding sides, but sometimes it's necessary when you don't have a corresponding side in an angle. So let's flip the page and try a few more. All right, we have a story problem for you. as we look at this, here's one reason to use the law of cosines. Let me get rid of that little, no, let me get rid of it. Okay, scientists use a set of footprints to calculate an organism's step angle, which determines if an animal or an organism walks efficiently. The closer your angle is to 180, the more efficient an organism walks. So we want to find this angle up here and determine if this angle is close to 180 and is this walking efficient. Okay, so if I'm using this angle, you can call this angle whatever you want. If you want to label them A, B, and C, that's fine. Like let's call this, side A, side B, side C. So let's find angle C. So if I set it equal to C squared, I have 316 squared equals 197 squared plus 156 squared minus 2 times 197 times 156 times the cosine of my angle, and we called this C. Okay, you can pick letter X, you can pick whatever you want. All right, 316 squared is 99,856. 197 squared plus 156 squared is 63,145 minus 2 times 197 times 156 is 61,464 times the cosine of C. So same process again. Let's get rid of the 63,000. When I do that, I get 36,711 equals negative 61,464 cosine of C. When I divide by negative 61,464, what I get as a decimal is negative point, and now I'm going to go 3 places because rounding wise didn't work so well, 597, and I'd like it as accurate as I can. So I'm just going to go one more place, and going one more place will never hurt. If I inverse cosine the negative 0.597, what I get is that angle C is 126.7 degrees. So how efficient is this organism? Not super efficient, but decent, right? I mean, at least it's over 100 degrees. Again, they want it closer to 180, but in this case, it looks like they walk decently. They maybe have a hip problem. Who knows? Okay, so this is one of the application questions that you could see. It's this idea that we give you a problem behind it, but you can still actually draw the picture and find law of cosines. We gave you an area formula when we did the last section, and we want to just give you another one here too. And the reason we give you this is you'll need a separate area formula for when you use all 3 sides. And so the area is the square root of s times s minus a times s minus b times s minus c, where s is 1/2 times the sum of all 3 sides. And so what I'm going to do is kind of show you this as we go through. There's 92 feet, 64 feet, and 130 feet. So we got to start by finding s in order to be able to find the area. So we take 1/2 times 92 plus 64 plus 130. We stick this in our calculator, and what you end up getting is 143. Okay, so in order to find the area says you take your s, which is 143, then you multiply it that minus one side, 143 minus 92, and 143 minus 64, and 143 minus 130. And so you do what they call the semi-perimeter, which is s, and then you do s minus each of the sides. What I would suggest to you to eliminate errors calculator-wise is I would actually find each of these numbers. So 143 minus 92 is 51. 143 minus 64 is 79. 143 minus 130 is 13. You plug it in your calculator, you square root it, and I believe you get about 2,736.77 feet squared. Again, it's an area, so you need some sort of label to it. But this is kind of the idea going through. So what I would like you to do is do these two area ones on your own, since we didn't really have any on your own this time. And the area is really the nicest of them all. Again, this is a formula I will give you, but you have to know when to use it. Okay, thanks for watching 13.6. This is the end of chapter 13. This is the last video you have to watch. Enjoy.